So we're going to finish off this chapter today. Remember, Tuesday you guys have a quiz on 4.3 and 4.4. So 4.3 basically dealt with rational exponents, and then 4.4 deals with radicals. And the connection is that we've seen that when you have any base raised to a rational exponent, how come you're late? Okay, we need to be to class on time. Whenever you have any base to a rational exponent, you can write it as a radical. And so that's the connection between rational exponents and radicals. So yesterday we saw that we can convert from mixed radicals to entire radicals. Remember, a mixed radical is where you have a mixture of a number in front, a coefficient, that's a rational number, and a radical, that's an irrational number. So today we're going to see that we can simplify some radicals to make them a mixed radical. And it starts with reviewing what perfect squares are. Perfect squares are numbers that when you take the square root, you get a rational number. Okay? And perfect squares, the ones that we use often are 1, because the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, and so on. So what we have there is we have a partial list of the first 15 perfect squares that exist. But that list goes on forever and ever and ever. And when you simplify a radical that is a square root, we need to express the radicand. Remember, the radicand is what number is under the radical as a product of two factors. Factors are things that multiply together. So you're looking for two numbers that multiply together to get whatever numbers under the radical. But the key is one of those must be a perfect square. So the example that we have there is that root 20 could be written as root 4 times 5. 4 times 5 is 20, right? Now, there are other numbers that multiply to get 20. For example, 2 times 10 can also be multiplied to get 20. The problem, though, is that neither 2 nor 10 is a perfect square. One of the numbers that you choose must be a perfect square. And so you can see that root 20 is broken down to root 4, root 5. And the reason those two are chosen is because 4 is a perfect square. And the square root of 4 is 2. So that's where the answer of 2 root 5 comes from. And that is equivalent to what we started with. And you can use your calculator to confirm that. If you take the square root of 20, and we did this yesterday when we checked our answers, it's that decimal. 2 root 5 should be the same decimal. And it is. So they are equivalent. They're just in different forms. We started with an entire radical. We change it to a mixed radical in simplest form. And just like whenever you have a fraction, you always reduce the fraction. The same thing applies with radicals. You always simplify the radicals by breaking them down. So the first example says, express each as an equivalent mixed radical in simplest form. And again, we've got our list of perfect squares above. So what you're looking for the largest number from this list that divides into 27. And 9 is the largest number from that list that divides into 27. Root 27 could be written as root 9, root 3. Okay? They are both radicals. We're using, again, that relationship for multiplying radicals that root a times root b is equal to root a times b. And it works both ways. Root a times root b equals root ab. Okay? And now, because the square root of 9 can be written as 3, because 9 is a perfect square, the square root of 9 is 3, there's our answer. You cannot do anything with root 3. There's no perfect square that divides into it, except for 1, but you go root 3 times root 1, you still have the root 3. But there's our answer. We've taken root 27, which was an entire radical, and we've written it as a mixed radical in simplest form. And once again, you can always check these to make sure that your answer is equal to what we started with. If you put both expressions in your calculator, you get the same decimal. tells us that our answer is equal to what we started with. And again, we've changed it from an entire radical to a mixed radical, which is what we're asked to do. So for root 50, again, you do a quick scan of that list of perfect squares above, and you should realize that, Princess, put your phone away, the largest perfect square that divides into 50 would be 25. You break root 50 down to root 25 times root 2. 25 times 2 is 50. But the square root of 25 is 5, so that becomes 5 root 2. There's the answer, which we can check to make sure that the original expression is equal to the one we got. Same decimal. So they're equivalent. They're in different forms, right? We started with an entire radical. We wrote it as a mixed radical. It's a mixture of a rational and an irrational number. Now for question C, you might look at that list and you might say, well, I know that 4 divides into 48. And you could take your calculator and go 20 or 48 divided by 4, and you would get 12. So you could say this is equal to root 4 root 12. And 4 is a perfect square. The square root of 4 is 2. But this one is not done because the 12 can be broken down further. 12 is also divisible by 4. So we would have to do another step here and break down the root 12 to another root 4 times root 3. The square root of 4, once again, is 2. And those 2's in front multiply together to get 4. There's the final simplified answer. Now, the fact that it took 2 steps to get there is fine, but it also tells me that we actually could have done it in 1 step. Because instead of taking 4 and dividing it into the 48, you also could have done this by realizing that 48 can also be found by going 16 times 3. You could go root 16, wait outside please, times root 3, and the square root of 16 is 4. So you see you got the same answer, only in 1 step instead of 2. And it doesn't matter if you take 2 steps, that's fine, as long as you get there. But it is important to realize that once you get your answer, you should take a quick look at the radicand you have left, Keen, and make sure that it can't be simplified anymore. It doesn't matter if it takes you 2 steps to get there, as long as you get there. So try those next 2 on your own, and then we'll check them. So again, look at that list at the top. The largest perfect square that divides into 40 is what, Keen? The largest perfect square that divides into 40 is 4. This is the same as root 4, root 10. The square root of 4 is 2. And again, you have to understand, and this is a mistake that seems like every time I teach this course, 1 or 2 of my students make this mistake. They write that as root 2 times root 10, and that's not correct. You've taken the square root of 4. That's where the 2 came from. The square root has done its job. You took the square root of 4. It's just 2 root 10. Okay, and again, 2 is a coefficient. It's written basically the same size as the 10. It's not an index. We've talked about that, right? If you have cube root, that means an index of 3, then you're going to have to write the 3 small and raised. That's an index. This is not an index. It is a coefficient. So it is the same size as the 10. It's not written up at the top and raised. Okay, who got root 63? Who thinks they got that one? Yes, Princess. Sorry? Okay, and how'd you figure out that 9 worked? Did you just look at 63 and know it's divisible by 9?
Yeah.
Okay. The other thing you can do is take your calculator. You go through that list of perfect squares. The first perfect square that we would use potentially is 4. So take your calculator and divide 63 by 4. It won't go evenly. You'll get a decimal. So then you go to the next perfect square, which is 9. And if you go 63 divided by 9 in your calculator, you'll get 7. Which means 9 times 7 is 63. It is. That's why I told you, Kitty. So we break that down to root 9, root 7. And so what's our final answer, Allie? 3 times the root of 7. That's right. That 3 is a coefficient. It's not an index. Okay. And again, you can always check these. The root of 63 is that decimal. That's the same as the root of 7. Sorry, 3 times the root of 7. Same decimal, which tells us that our answer is equivalent to what we started with. The only thing that would make our answer wrong is if that root 7 could be broken down any further, but it can't. Okay? Now, f is already a mixed number, but it's not simplified. And you're going to see ones like this, where you might have a mixed number and it's asking you to write it as a mixed number in simplest form. So the fact that you have a mixed number to begin with doesn't change the way it's done. You need to simplify it further. And in this one, the root of 16 is actually 4. 16 is a perfect square. So this is 5 times 4, which is 20. In this case, you don't end up with a radical in the end because 16 is a perfect square. But you could still check it on your calculator. If you go 5 root 16 on your calculator, it should spit out 20, and it does. So the answer we got at the end is equivalent to what we started with. It works. So again, these last 3, yes, sir. 5 is not a perfect square, right? So that's a good question. Remember, you have to look at that list of numbers at the top and see which of those would divide evenly into the radicand. There is no perfect square that divides evenly into 10. Right? 4 does not divide evenly into 10. It'll be a decimal. The next perfect square is 9. It does not divide evenly into 10. It will give you a decimal. Make sense, Kai? Okay, good. Good question, though. So again, these last 3 are already mixed numbers, but they're not in simplest form, so we need to break them down. Root 24 would be root 4, root 6. The largest perfect square that divides into 24 is 4. And the square root of 4 is 2. So once again, the radical sign has done its job there. We took the square root of 4. So it's just 2, not root 2, 2. And then you can multiply the 2 numbers in front. 3 times 2 is 6. So there's the answer that we've gotten. 6 root 6. Okay, the 6 under the radical cannot be broken down anymore, so we're going to assume that we're done. But we'll check to make sure that what we got at the end is equivalent to what we started with. And it is. Yes, sir. An entire radical? Sure, you could, but what does the directions ask us to do? Express it as a mixed radical in simplest form. That's what we're being asked to do here. But then you wouldn't be answering the question. You'd have to then take the whole one and convert it back to a mixed number, a mixed radical. If you want to do that, you could, but I think you're giving yourself more work. I do. But yes, to answer your question, if you wanted to do it that way, you could. But that would take at least 2 steps where we did our answer in 1 step. Okay? So you're giving yourself more work. So in order to determine the largest perfect square that divides into 108, we will use the calculator. Okay? And instead of starting at the lower end, I'm going to start at the upper end. Okay? So I've got 100 as a perfect square. I mean, I think we can all agree that just by looking at that, you know that 100 will not divide into 108 evenly. It'll be a decimal. Same thing with 81. Will not divide into 108 evenly. It'll be a decimal. Let's check 49. It's 108 divided by 49. Doesn't go evenly. Let's check 36. The next perfect square as we go down the list. And there we go. 108 divided by 36 is 3, which means 36 times 3 is 108. The largest perfect square that divides into 108 is 36. So this will be 2 times the root of 36 times the root of 3. And then we'll take the square root of 36 and get 6. And multiplying 2 times 6 gives us 12 root 3. So there's our final simplified answer, which again, we can check on our calculator. The original expression, 2 times the root of 108, is that decimal. It's an irrational number. It's a decimal that doesn't repeat, doesn't terminate. And we've talked about that. Whenever you take the square root of a number that's not a perfect square, you get an irrational number. But that should be equivalent to the answer we got at the end, which it is. So that tells us that our answer is equal to what we started with. The only other thing that you would want to check is to make sure that the number under the radical cannot be broken down anymore, and it can't. Are you okay, Ali? You're okay? Because you had this look on your face, like either you had gas, like a bad stomach cramp or something, or maybe you were having trouble understanding. I hope it was the understanding part. We don't need to show of hands to see who else is thankful that you don't have gas right now. Okay, 5 root 18. We need to break down the root 18. So Declan, what's the largest perfect square you think that divides into 18? Absolutely. 9 times 2 is 18. So root 18 would be broken down to root 9, root 2. What would you do now, Sophia? Phone a friend? Is? And now what? Okay, there's our final answer, which you could check. Again, the directions asked us to write it as a mixed radical in simplest form, so that's what we've done. We can do the same thing with cubes, cube roots, but we need to have our list of perfect cubes, which are written at the top there. So they're done exactly the same thing, only these are now all cube roots. The cube root of 8 is 2, right? The cube root of 27 is 3. The cube root of 64 is 4. The cube root of 125 is 5. And the cube root of 216 is 6. You could generate that list by working backwards. Take your calculator and go 2 to the power 3. That gives you the 8. 3 to the power 3 would give you the 27. 4 to the power 3 would give you the 64. So you can generate this list on your own. So for the cube root of 24, I mean, if you did that in your calculator as it is, you're going to get an irrational number. It's a decimal that doesn't repeat, doesn't terminate. Irrational. We want to write it as a mixed radical in simplest form. And if you look at the list above, 8, which is really our first perfect cube that we would use, divides evenly into 24. So this would be the cube root of 8 times the cube root of 3. So again, the cube roots, well, that's an index. So it's written higher and smaller to show that it's an index. And the cube root of 8 is 2. So again, we've taken the cube root of 8. That cube root for the first part has done its job. So it's gone. It's just 2, which is a coefficient. And again, you maybe use your calculator to help you to find the largest perfect cube that divides into 54. So I just used 8. Let's see if 27 will divide into 54, and it will. It goes in there exactly twice. So cube root of 54 would be the cube root of 27 times the cube root of 2. And the cube root of 27 is 3. And you know, when we did the square root ones, we checked in our calculator, so we can do the same thing here. The cube root of 54 is that non-repeating, non-terminating decimal, right? It's an irrational number. Well, that should be equivalent to the answer we got, which was 3 times the cube root of 2. And it absolutely is the same decimal. So the answer that we got is equal to what we started with. The last one here, 5 times the cube root of 128. So as if I start at the larger numbers and work my way down, again, the number is the cube root of 128. So if we take 128 and we divide it by 125, it's not going to give us, it gives us a decimal. We don't want to have any decimals. So instead of dividing by 125, what if we divide by 64? That's the next number down in our list, and it does work. 64 times 2 will be 128. So this will be 5 times the cube root of 64 times the cube root of 2. And the cube root of 64, we wrote it above there, is 4. So it'll be 5 times 4 times the cube root of 2. Again, I've taken the cube root of 64. So the cube root has done its job. That is just 4. And then when it's multiplied by the 5 in front, we'll get 20 times the cube root of 2. And so there's the final answer, which again, you can always check in your calculator to make sure that it's equal to what you started with. Now for number 3, order these irrational numbers from least to greatest. There's a couple different ways you could do them. One of them would just be put these numbers in your calculator and get them as a decimal. Or we can write them all as radicals in simplest form. So Brock, what will you do for the first one? So what would? Do I need to take your phone away again? Pardon? It just so happened I looked up when you were on it, I guess. Pardon me? Okay, but you know what the rule is, right? Thank you. So because this is the square root of 18, you're looking for the largest perfect square that divides into 18, which would be 9. So 2 root 18 could be written as 2 root 9 root 2, because 18 is 9 times 2. And the root of 9 is 3. And again, when you take the square root of 9 to get 3, the square root sign has done its job. It's gone. It's just 3. And 2 times 3 is 6. So if we look at the other 3 numbers we have, we can see we've got a 3 root 2. We know that 6 root 2 is going to be bigger than 3 root 2 because the coefficient in front of the root 2 is bigger. So this is how we're going to compare all these numbers, because we're going to be able to express them all as root 2s. Root 8 would be root 4 root 2, and the square root of 4 would be 2 root 2s. So that's smaller than 6 root 2s, and it's also smaller than 3 root 2s. So far, that's our smallest number. But now we need to do root 32, which would break down to root 16 root 2, and the square root of 16 is 4. And so if we compare all the numbers now, we can see that the smallest number will be 2 root 2, which came from root 8. The next larger number would be 3 root 2, which was written as 3 root 2. Then 4 root 2, which came from root 32. And then finally 6 root 2 that came from 2 root 18. So now we've arranged them from smallest to greatest. By writing them all as radicals in simplest form, mixed radicals, it makes it quite easy to compare them. Quite easy to compare them. Okay? So you need to read the directions and make sure that you know what you're trying to do. So on this next page, we're going back to what we did yesterday. Write them as a mixed radical. No, I'm sorry. This is what we just did today. Write them as a mixed radical. Okay, so this is no different than what we just did. And these are all square roots. So you're looking at the list of perfect squares that I've written above. The root of 20 could be broken down to root 4, root 5. And when you take the square root of 4, it's 2, or 2 root 5. There's your answer, and you could check that. Make sure that you get the same decimal in your calculator. Root 75 would be broken down to root 25, root 3. Because 25 is a perfect square, that's why we're using it. And the square root of 25 is 5. It's 5 root 3. Again, the square root sign has done its job, so the answer or the coefficient is just 5. Not root 5, 5. 80 isn't one that's quite so easy to work with, so we'll use our calculator. We know that it's not divisible by 81, but let's see what happens when we divide by 64. Not going to use that because we get a decimal. Okay, what about 49? Not going to use that because we get a decimal. 36. Again, we get a decimal. Not going to use that. I think you should know that 25 won't work because the multiples of 25 are 25, 50, 75, 100. And again, we get a decimal. But 16 will work. If you divide 80 by 16, you get 5. So this will be written as root 16, root 5. And the square root of 16 is 4. So there's your equivalent radical as a mixed radical. Root 44. 44 can be divided by 4. It'd be root 4, root 11. And the square root of 4 is 2. Again, the radical sign has done its job, so it's gone. You're just taking the square root of 4, and it is 2. Not root 2, but 2. And these next ones are cube roots. So we need to look at the list above. And I think we've already done cube root of 54 before. That's the cube root of 27 times the cube root of 2. 2 times 27 is 54. And the reason we're using 27 is because it's a perfect cube. The cube root of that is 3. So you'll get 3 times the cube root of 2. So we already did this one back a couple pages ago. But this next one we didn't. So again, we just have a partial list of the perfect cubes there. So you should look at that and realize that 375 is divisible by 125. 125 times 3 is 375. So this would be the cube root of 125 times the cube root of 3. And the cube root of 125 is 5. So there's the answer. And we already did the cube root of 128 a couple pages ago. 64 times 2 is 128. So it would be the cube root of 64 times the cube root of 2. Now we're going back to what we did yesterday. It says convert each to an entire radical. So you have to read the question, find out what you're being asked to do, and then do it. So in order to write them as entire radicals, you need to write the coefficient as a radical. So for part A, because the second part of this is the cube root of 4, you need to express 9 as a cube root. You need to know the cube root of what number is 9, and you can get that by working backwards by going 9 to the power 3. 9 cubed is 729, so therefore the cube root of 729 is 9. 9 written as a cube would be the cube root of 729 times the cube root of 4. And now you can multiply these together and your answer will be a cube root. So 729 times 4 is 2916. There's our answer as an entire radical. And like we've been doing, you can always check these. If I take the cube root of that previous answer, that number, it's that decimal, well, that should be equal to the original. 9 times the cube root of 4, same decimal. So our answer is equivalent to what we started with. It's correct. Now this next one is 4.2 times the square root of 18. So you need to write 4.2 as a square root. And you can do that by working backwards, by squaring the 4.2. You get 17.64. So that means the square root of 17.64 is equal to 4.2. So this will be the square root of 17.64 times the square root of 18. And we can multiply those together. And this would be the square root of 317.52. Question C, we need to write the 1/2 as a radical, and we can do that by squaring it. If you square the half, you're going to square the top number and the bottom number. This will be the same thing as the root of 1/4 times the root of 10. The square root of a quarter is a half. And now if we multiply those together, and again you can do it on your calculator, you can go in brackets 1 divided by 4. There's 1/4. And that's multiplied by 10. You'll get 2.5. So this will be the root of 2.5. And again, we can check that. If we take 1/2 or 0.5 times the root of 10, it's that decimal. Well, that should be equal to the root of the answer we got, 2.5. Same decimal. So it checks. Right? So we took a mixed radical, wrote it as an entire. This next question, again, we're working backwards now. We have entire radicals. We want to write them as mixed radicals. So the root of 27, that's a square root. So we want to find the largest perfect square that divides into 27, and that'll be root 9 times root 3. The square root of 9 is 3, so we'll get 3 root 3. Question B is the root of 50. That would be the root of 25 times the root of 2. The largest perfect square that divides into 50 is 25, and the square root of 25 is 5. The answer is 5 root 2. Again, notice that the radical has done its job. When you take the square root of 25, it is just 5, not root 5, just 5. Root 48, we did this one earlier today. We found that the biggest perfect square that divides into 48 is 16, and this allows you to do it in one step instead of two. Now this next one is dealing with the fourth root of 80. So we haven't talked about fourth roots before, but you can generate a list of numbers that have a fourth root by working backwards. 2 to the fourth is 16. So the first fourth root we would use would be 16 because 2 to the fourth is 16. 3 to the fourth is 81. So that might be the next number that we would use for fourth roots. That's 3 to the fourth. Okay. 4 to the power 4 is 256. So this is just a very small partial list of numbers that have a fourth root. And the first number in this list is 16. If you take your calculator and see if that divides evenly into 80, you will find that it does 5 times. So you could write this as the fourth root of 16 times the fourth root of 5. And the fourth root of 16 is 2. So it's 2 times the fourth root of 5. There's the answer. And again, these can always be checked. The fourth root of 80 is this decimal, this irrational number. That should be equal to 2 times, whoops, try that again. I think I might have to put the fourth root of 5 in first, it looks like. And then multiply by 2 after, looks like. Or I could have gone 2 times the fourth root of 5 if I wanted to. But, Keen, you see we get the same decimal as the fourth root of 80, so our answer is equivalent. Okay? So just make sure that you know what you're being asked to do If you want to write it as a mixed radical, no matter what the original question is, it might be a mixed radical to begin with, but you still need to write it as a mixed radical by simplifying it. Example 6 says a CB mine located in this place in Saskatchewan. In 2007, the mine produced a daily average gold great enough to fill a cube with a volume of 180 cubic centimeters. If 5 days of gold production is cast into the cube, what is the edge length? So the volume of a cube is each edge length cube. A cube is a special box where the length, width, and height are the same. That's what makes it a cube. The 3 dimensions are the same. And so one edge length times a second edge length times a third edge length will give you the volume. That's why volume equals L cubed. And we're told that the volume is going to be produced from 5 days of gold. Each day they get about 180 cubic centimeters, and we're going to have 5 days worth of that. So 5 times 180 is 900. So 900 cubic centimeters is what L cubed equals. And then to find out what L, we got to get rid of what L is. We got to get rid of the cube by doing the opposite of cubing, which is cube rooting. And whatever you do to one side, we need to do the same thing to the other. We take the cube root of both sides. So on the right side, the cube root cancels with the cube, and you're just left with L. And on the left side, you've got the cube root of 900 centimeters cubed, which we are going to simplify. We're going to simplify that. So we need to look at our list of perfect cubes and find out what's the largest perfect cube that divides into 900. So if we write the list of perfect cubes on the side here, now we don't use 1, even though it is technically a perfect cube, but 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and you can use your calculators to generate these. 6 cubed is 216, 7 cubed, don't remember what that is off the top of my head, so I'll use my calculator for it, is 343. I can try one more. What about 8 cubed? 8 to the power 3, 512. I don't need to go any further than that. In fact, 512, I think we can already know that it's probably not going to divide into 900 evenly. The 900 divided by 2 would be only 450. But just to check, 512 doesn't divide into 900 evenly. 900 divided by 343 doesn't go evenly. Next, we'll try and divide it by 216. And we'll keep working our way down the list until we find something that goes evenly. That's probably the closest that we're going to get. Okay, even though it's not an integer, at least it's a terminating decimal. But we'll check the other ones just to be sure. 900 divided by 64. That's a longer decimal, so I don't want to use that. 900 divided by 27. Repeating decimal, don't want to use that. And 900 divided by 8. I could use that one as well if I wanted to, because at least I get a number that only has one decimal. But it's always a good idea to use the largest perfect cube. And in this case, I'm going to use the cube root of 125, which is 7.2. So L will equal the cube root of 125 times the cube root of 7.2. And the cube root of 125 is 5. So there's our answer. The length of each edge as a mixed radical in simplest form would be 5 times the cube root of 7.2 centimeters. Okay? And I don't think we need to do the next one. It's the exact same type of question. So you're going to do this worksheet. Yep. You're going to hand this one in for marks. I wasn't going to, but you asked, Keen. You asked for it. No, I was. I was going to make this do. So again, remember, you're asked to simplify these, so they all need to be written as mixed radicals. Even though some of them already are mixed radicals, you need to simplify them down. All your answers need to be mixed radicals except for, I think, question F. You're actually going to get a numerical answer for that, and we saw ones like that before, right? But I think all the rest of them, they will be mixed radicals. So yes, put your name on it. You're going to hand this in. Remember, Tuesday you have a quiz on everything we've learned so far. You can grab your assignments out of there? Absolutely. Okay?